Okay, so let's just accept that and exit. Okay, so we've got our setup, which is our accelerometer, connected to a microdot to a BNC, and then a BNC to this cable here, which is the one that's accepted into the machine. Okay, we plugged it into channel 4, and we've selected Impact Echo as the app that we're going to use, just because it has time signal and a frequency FFT. Okay, and these are the two things that we wanted to see. We're going to turn it on. We're going to come into here. We're going to go to parameters, and it will default to displacement on, accelerometer off. Okay, so we need to switch those and then move the reference and the trigger. So trigger just means I'm going to listen to this sensor on channel 4 and I'm going to start my data logging. Okay, so that's why we need the trigger there. I forget what the ref is, but it doesn't hurt to have that set across there as well. Okay, so then looking on here, so this will turn it to metric. To be honest, there's no real reason to have it set to metric because we're not even using the Impact Echo aspect of this. Okay, first one here is my sampling rate. So the smaller the number on this, the smaller the distance between each of the points that I'm data logging at. So a small number means that I'm getting a better estimation of my data. Okay, I've increased the record to 1024. So this is seven microseconds, and we're going to do 1024 of these. So that's basically the length of the data file that I'm collecting in time. Okay. I put on a pre-trigger. So pre-trigger means that when it's triggered, it's actually going to record the 80 points before the trigger as well. Okay, so it's always listening, but when we take our snapshot, we're going to go, here was my trigger, and take the 80 points before that. Okay, always a good idea to get pre-trigger. Trigger level doesn't seem to be an issue. This is default at the moment, but that's basically how much energy do I need to trigger the data file. Okay, and I've turned the solenoid off, okay, because I want to use the sensor as the trigger. Okay, no need to use the solenoid because the solenoid is part of the Impact Echo. And because we're just messing around, I'm going to set records to 1. Okay, but basically the more records we have, the more times we're going to impact, and it will average the signal. And so in reality, when you're doing the testing, you're going to do probably at least 3 impacts on each location to make sure you get the best data file, because it means you can go accept, reject, accept, whatever, and get your average always better. You'll get smoother curves, all that sort of stuff. But because we're messing around with the settings, it's best to set it at 1, because then you don't have to do 4. Like it defaults to you having to do 4 every single time, which can be annoying when you're just doing a little bit of testing. If we go back out of this, okay, the only setting that we could have potentially wanted to mess with is the gain. Okay, it's set to 1 at the moment, and from our initial impact it seems like 1 is okay, but I'll show you what would happen if we did a higher one. So we'll press test. It will ask for the impact. Now this is interesting. So the different impactors will give different frequency content. Okay, so here we've got our small little one. Okay, and you can hear that really pinged. That was quite a high frequency. And although this is recording here in millimeters, this is actually frequency down here. It's just that it's used the velocity to calculate a thickness in terms of Impact Echo. We're essentially ignoring the fact that this is in millimeters at the moment. What we're really interested in is the frequencies behind this, which should be recorded, and if they're not, we can back calculate them anyway. Okay, now what you'll note here is this is my time signal, so this is my sine wave, okay, my raw data, and I'm using 25% of the range, okay, which is pretty acceptable. Okay, yeah, I mean that's fine. If if we were getting less than 10%, then we might turn that gain setting up. And we could even set the gain setting up again, but we might find you don't want to use more than 90% of the scale, because then you risk clipping your data. Clipping means it's out of the range of the machine. You just basically get max, okay? Instead of getting an actual number for it. So this is all pretty good. We're happy with this. We'll accept that. And then what we can do is we can save it. Okay, at the moment, I haven't changed the file name setup. So at the moment it's got IE101-NDE, okay? But we could change that by going into files and create a new name and file number. So then all we would do is just punch in a new one. Let's change. So we'd go, let's go plate, P-L-A-T-E, and accept. And we'll start at, we can either start at 0 or 1. When you're doing references, the initial origin should be 0, okay? But if you're not gridding it out, then 1 is fine to use as well, okay? So we'll put 1 in.
So you would think that for something like this, we would draw like a grid and be testing.
Yeah, and then that would mean that 0 would actually be at 0 distance. Yeah, okay. So we'll accept that. It's happy with that, okay? So, and we can return, which is 0. We're back out, and we can do our test. Now, the reason why I'm going to do another test, whoopsie, back, test, okay, is I'm going to use a different impactor, okay? Now you'll hear immediately quite a different impact. Okay, there's a lot more low frequency in that impact, okay, which to be honest is probably best because we want to excite the natural frequency, I think. Well, we want to excite as much of the spectrum as possible, like mode 1, mode 2, mode 3, mode 4. I suspect because of the frequency content of this that we might struggle to get all of the modes, but you know, you're not going to know until you get on site, okay? So yeah, and we've only used 27%, so again, our gain setting seems to be fine. This looks like rubbish impact echo data because it keeps on ringing, but that's what we would expect from knocking on a piece of steel, so that's fine. We can see here, we can see a peak here, and if I move my, well, let's accept that. If we move our little, did you see that little black thing just sort of slide around? Yeah, okay, so we can just, that's how we pick out what the peaks are. Oh, there we go. So that was where our first peak is, another peak, here's a peak, and here's a peak. Okay, so I think all in all that the setup is pretty good. I think that you're going to get the full frequency spectrum, which is what you want. So I think from this end, I mean, Will might have a different mindset, but I think that this basically covers everything that you really want to do. It then now just comes down to the setup of how you're going to data collect, and then I guess the other aspect is the interpretation after that.
Yeah. So how do we, you know, what are we looking for to see the difference between a...
Okay.
Would it maybe be worth, for example, just doing a quick hammer tap before we even start listening? Anything that's hollow, we kind of like just do a little chalk outline and we can sort of cross-reference what sounds hollow just audibly, and then we grid it and then we see how that matches.
Yeah. I would probably set up some sort of test bed or something like that, a prototype,